Radhe Radhe students, today we are going to learn conservation of linear momentum and we will also solve numericals based on Newton's law of motion. In previous lectures, we have already completed three laws of motion and also we have learned about force and its effect. So let's start. Suppose this mass m1 is moving with initial velocity v1 and m2 is moving with initial velocity u1 and u2. And after some time they collide because I have taken u1 is greater than u2, right? So after collision, let's say v1 m1 starts moving with v1 and m2 starts moving with velocity v2. During collision, you can clearly see here that m1 is exerting force on m2 in rightward direction and m2 is exerting force on m1 in leftward direction, and these forces are action reaction pair, so their magnitude are going to be equal but their directions are opposite. So we are going to write here f12 is equal to minus of f21 because magnitude are equal but direction is opposite. So if you use Newton's second law to write this value of force, then you have to write f equal to mass into acceleration. M and acceleration is change in velocity upon time. So m1, for m1, if you see, its final velocity is v1 and initial velocity u1. So v1 minus u1 upon delta t is acceleration. For m2, if you use Newton's second law, then you have to write m2 change in velocity v2 minus u2 upon time interval for which this velocity has changed. This time will cancel out because for same time interval, these two objects are exerting force on each other. So if you solve these two values, you will get m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. We will use this formula to solve several numericals. So let's start solving numerical. So first type of numerical. So let's start solving problem on NLM. So first type is problem based on conservation of linear momentum. So here I have taken an example of bullet gun system where I will use 1 for bullet and 2 for gun. We already learned this formula m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So as we know that this gun and bullet are initially at rest before firing, so ub and ug are going to be 0. So if you can put here 0. So if you solve this equation, you will get vg equal to, this will become negative, minus vb ub upon mg. So out of these four quantities, 3 will be given in your numerical and you have to find out fourth one. So you can solve this kind of numerical very easily. So let's move to our next type, type 2. In type 2, we will learn how to find tension in the string. Suppose these three blocks are connected with strings and we have to find tension here and here. This tension force will act between 1 and 2 kg object, and we have to also calculate tension on this rope which is acting between 2 and 3 kg block. So this tension force will act in leftward direction for 3 kg object and in rightward direction for 2 kg object. Similarly, this tension force will act in leftward direction for 2 kg object and in rightward direction for 1 kg object. So to solve such kind of numerical, you have to take whole this system whole as a system, and 12 Newton will act as external force for this system. So according to Newton's second law, F equal to ma. So F external is 12 Newton, which is equal to mass into acceleration. What is mass? 3 plus 2 plus 1. Total mass is 6 kg. So 6 into A. So from here we can find this value A as 2 meter per second square. To find tension force acting between 1 and 2 kg block, we have to draw free body diagram of this 1 kg block. So only force acting on this 1 kg block is T1. So this force is responsible for acceleration of 1 kg object. So let's write Newton's second law for this 1 kg object. Force equal to mass into acceleration. Mass of this object is 1 and its acceleration is same as common acceleration of the system, which is 2 meter per second square. So tension force is going to be 1, which is mass, and acceleration of system 2. So this tension force T1 equal to 2 Newton. To find tension force acting between 2 and 3 kg, we will draw free body diagram for 2 kg object. 2 kg. So rightward force acting on this 2 kg block is T2 and leftward force is T1. So total force acting on this block is T2 minus T1, and according to Newton's second law, total force acting on any block is equal to mass into its acceleration. Its mass is 2 and acceleration of 2 kg block is same as acceleration of this system, which is 2 meter per second square. 2. We have already calculated this value T1, 2 Newton. So T2 minus 2 equal to 4. So T2 equal to 4 plus 2, 6. So T2 is 6. You can also find this value T2 by drawing free body diagram of 3 kg object, right? So you can solve this numerical way by. So now we'll try to solve our third type of problem, which is based on pulley block system. Okay, so here one pulley is attached with some ceiling and 2 blocks are hanged with the help of a rope. Mass of this block is 2 kg and this block is 1 kg. So to find acceleration and tension in this rope, we have to take some variable. Let's say this block is moving downward with acceleration A and this is moving upward with same acceleration A. And since they are connected through a single rope, so tension on both sides will be same. So if you try to draw free body diagram of 2 kg block and indicate all the forces acting on this block, then you have to indicate a downward force which is equal to 20. 20 means mg, mass of this block is 2 and I have taken value of g as 10. So 20. And upward force acting on this block is T. Is there any other force acting on this block? No, only 2 forces are acting. So since this block is moving in downward direction, so 20 Newton force is greater than T. So I will write here Newton law, total force 20 minus T equal to mass of this object 2 into its acceleration. This is equation 1. And if you try to write Newton's second law for this object, you will have to draw free body diagram of 1 kg block. 10 Newton force will act in downward direction and T in upward direction. Since this block is moving in upward direction, so T is greater than 10. So T is upward direction minus 10 acting in downward direction. Total force equal to mass of this block 1 and acceleration A. This is our second equation. As you can see here, there are only 2 variables and we have also 2 equations. Variables are T and A. Here also T and A. So we have 2 variables and 2 equations. So we can easily solve these 2 equations and get value of T and A. Okay. So I hope you understood these numericals, and so that's all in this lecture. I hope you understood all these concepts. Try to solve more numerical based on these concepts from your textbook. Okay. So that's all. Bye. Radhe Radhe to all of you.